Hello everyone. In this video, we're going to be solving a logarithmic equation from ARML, which is American Regions Math League. ARML is a very prestigious math competition. I'll share some links down below. You can also find some books that will help you prepare for math competitions like ARML on my Amazon page. So we have log with base 2 of log with base 2 of x equals the same thing with base 4s. So we have the same type of equation. We have x's in two places, but the bases are different. So I'll be presenting two methods, even though there is a third way to do it. We can maybe briefly just talk about it. All right, let's start with the first method. So for my first method, I'm going to use an awesome method that I almost always use, and that is called substitution. You knew that, right? So I'm going to go ahead and call this A. And since these two things are equal, this is also going to equal A. So log 2 to x equals A, and log 4x equals A. You know what I'm talking about, right? Okay, now let's go ahead and start with the first one. What does this mean? This basically means, by using definition of logs, that log x with base 2 log with base 2 of x equals 2 to the power a. And if you do the definition one more time, from here you get x equals 2 to the power 2 to the power a. Make sense? So if you use the log backwards, you're going to get the exponential. If you invert the exponential, you're going to get the log. Of course, the base is always going to be the same. Make sense? Now, we got this for base 2, and with base 4, it's going to be the same thing, but it's just going to be 4. So x is going to be also 4 to the power 4 to the power a. So this could also be like an exponential equation, which is given in this form, but it was given in logarithmic form. Okay? So since these two things are equal to the same thing, then they are equal, right? So let's go ahead and set them equal to each other. 2 to the power 2 to the power a equals 4 to the power 4 to the power a. Awesome. First of all, this might look like a complicated equation because we kind of have a tower, right? And the a is all the way on top. But don't worry, we have an advantage, which is the base. The base is 2 here, and the base is 4, and 4 is a power of 2. That's nice. If it wasn't a power of 2, then it will be a different story, but we've done similar problems before, so you can go ahead and take a look at them. So here's what we're going to do. Since 4 is a power of 2, we're going to write it as 2 to the second power and then raise it to the power of 4 to the power a. Obviously, 4 to the 4 to the a doesn't mean 4 to the 4 to the a, because that would be 4 to the power of 4a. Why would you write it as this, right? Anyways, hopefully that's understood. And now we can go ahead and multiply the exponents, because that's what the rule says, right? Multiply these exponents, and you get 2 to the power 2 times 4 to the power a. Now notice that the bases are equal, so are the exponents. From here we get 2 to the a equals 2 times 4 to the a, and then of course it makes sense, right? It only makes sense to bring the a's together, the variables. So 2 to the a divided by 4 to the a equals 2. So we isolated the constant and the variables. Now we can go ahead and use the properties of exponents. I'm probably thinking about making a separate video on properties of exponents because we use them all the time. What do you think? Would it be a good idea? Just let me know. Anyway, so, but in this case, we have a common exponent, so we can kind of divide the bases 2 over 4, but I can write it as 1/2. Let's take a shortcut here real quick. And then 2 is basically 1/2 to the power -1 because it's the reciprocal. This implies a equals -1. See that? Okay. Now, if you didn't get that, you could also invert these and get the same answer. Make sense? I mean flip. I probably shouldn't say invert, because invert can mean finding the inverse. Well, it's kind of multiplicative inverse. That's what it is. So a is equal to -1, but what is a? A is nothing. X is 2 to the 2 to the a. So let's go ahead and plug it in. X is 2 to the 2 to the a, right? What is a is a good question. Can you find a in terms of x? Of course. It was given at the beginning, right? Obviously. That was the equation. So since a is equal to -1, it's going to be 2 to the power 2 to the power -1. But 2 to the power -1 just means 1/2, and 2 to the power 1/2 in the real world, of course, means square root of 2, right? That's a fractional exponent. But would it be the same if we use 4 to the 4 to the a? Absolutely, you can test it out. But x equals square root of 2, so this equation has how many solutions? 1, only 1. Pay attention to this fact, because when we do the second method, something is going to pop up. Okay, ready? Second method. So we have log 2x equals log 4x. Okay, I mean, those are the bases, right? So here's what I'm going to do. I could use as a third method change of base, but I'm not going to use it because I don't know why. I don't want to make it too long, I guess, but you can use it. And it would work like this. Like, let's say you have log 2 with a and log 4 with b. Then you could just convert both of these to log base 10, and it will look like this. And then from here, you can write log 4 as 2 log 2. That would cancel out, and you would get a ratio. Make sense? Okay, that's pretty much what it is. I gave you the outline. Hopefully, you can take it from there. Now, let's go ahead and focus on this method. So here's what I'm going to do. I'm going to write the 4 as 2 squared, right? Now, what happens when there is a power at the base? Now, we probably know that if we have log b to the n, this becomes n times log b with base a. But what happens if the base is raised to a power? In that case, you see how the n, you can bring it to the front. This time you can bring the n, but it needs to be a reciprocal because it's coming from downstairs. You get the idea? Okay, 2 stories, a is downstairs, b is upstairs, whatever. So this 2 can be brought to the front, but it's going to be with a 1/2. Okay, cool. And everything else is good. Now we get that from here. And of course, we have the left-hand side, which is now the right-hand side. So I'm going to go ahead and set it equal to log 2x. Okay, hopefully you get the idea. So here's what I'm going to do. After bringing the 1/2, I'm going to go ahead and put it back here and write this as, I should probably erase this so that you can clearly see. Okay, this equals this, right? Oops, didn't mean to do it. Okay, and then we're going to bring the 1/2 as a power, so it's going to be log 2 log 4x to the power 1/2, and that's going to be log 2 log 2x. All right, so far so good. Notice that this is all being done because I want to get an equation with the same basis. Makes sense? Cool. Now the arguments have to be the same, so these are the arguments. In other words, log x with base 4. 1/2 basically means square root, so I'm going to write it like that. And now to solve this problem, I want to square both sides. That makes sense, right? Let's get rid of the radical. And now we get log x with base 4 equals log x with base 2 squared. Okay, again, the relationship tells us I can write this as 2 squared and then bring the 2 to the front, but it's going to be 1/2. So this is going to be 1/2 log 2 of x equals log x with base 2 squared from here. Okay, so far so good. I hope I didn't lose you. Now we're going to use substitution because substitution is awesome, isn't it? Don't you think? If this is y, and don't ask why, we get 1/2 of y equals y squared. And then from here, we can safely say that, hey, y equals 0 definitely works. Divide both sides by y. If y does not equal 0, y will be 1/2. So there are 2 solutions. And what does that imply? Y is log 2x. So if y is 0, from here we get x equals 1. Uh-oh. A new solution, right? And if it's 1/2, obviously by definition, x is going to be 2 to the power 1/2, which is root 2. But we only had one solution with the first method. Where does this come from, right? Like a lot of question marks. Let's go ahead and take a look. What was the original equation? Always check the solution against the original problem. Not the modified version, but the original one. Now, if x is equal to 1, right, as claimed here, this is going to be 0. And that's going to be 0. But log 0 is undefined in the real world. So that solution is extraneous. It's extraneously not a solution. X equals root 2 is the only solution. And here's a nice graph. And here's the solution from Wolfram Alpha. Good job, Wolfram Alpha. You're awesome. And this brings us to the end of the video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.